Hey guys, back on the videos. We're going to look at exercise 5b today, which looks at domain and range for different functions. So I've got a couple of definitions that I want you to get down in your book, and then I'll go through a couple of examples for you so we can get started on the exercise on Wednesday. So first off, the first definition is a relation, which is simply a set of ordered pairs, which we've looked at throughout our topics, which is just ordered pairs is an x-coordinate and a y-coordinate. Okay, so for example, set S would have ordered pairs 1, 2, 3, -2, and 5, -3, as you can see there. So when you're asked to find the domain of a set of ordered pairs, or a domain of a function, a domain is simply all x values for which the relation exists. So for set S, that would be the first in each of the ordered pairs. So for set S, x exists at 1, 3, and 5. And then the range is all y values for which the function exists. So for set S, that would be 2, -2, and -3. Okay, so you're just reading off the ordered pairs for x and y values, which relate to domain and range. So just think domain is always x, range is always y. So make sure you get that into your books. All right. So let's take another look at an example here. So example for set B, you got 3 ordered pairs here, and you're asked to state the domain and state the range. So I'd like you to pause the video now and have a go at that. Cool. So hopefully you've had a crack and you've come to realize domain would be equal to -5, 4, 1, lining up with the x values in the ordered pairs, and the range would also be 1, 0, -2. And if you'd rearrange them in ascending order generally, so we'll go -2, 0, 1. Okay, so taking this idea a step further, looking at example here, so we've got 4 rule x and y, so you've got 2 variables in here where the rule is y is equal to x plus 2, and you've got elements x is equal to 1, 2, 3, and 4. State the range. So the reason why it doesn't ask you to state the domain is you can already see the domain for this function is stated in the question. It's x is equal to 1, 2, 3, and 4. So to find the range, you would simply substitute these values into the rule we have to find the y value. So x equals 1, y is equal to 1 plus 2, 3. Okay? So you can pause it here and have a stab at trying to find the next values for the next y values using that rule. So you'd have when x is equal to 2, y would be equal to 2 plus 2. It's equal to 4. When x is equal to 3, y would be equal to 3 plus 2, which is 5. And when it's equal to 4, y would be equal to 6. So the range is 3, 4, 5, and 6. Okay. Now, last question that we'll have a look at. And there are further examples in the textbook from page 176 onwards to help you out with this. But for the graph y equals x squared, state the domain and range. So graph and then state the domain. So this y equals x squared, thinking back to our graphs, y equals x squared is just a standard parabola, turning point 0, 0. Excuse the bumpy lines. Okay, and making sure you're always labeling. Okay, so you got 0, 0. The domain is, as this continues, if you imagine this line continuing on forever, it's going to keep getting wider and wider. So the domain would be all real x, so all real values for x. The range, on the other hand, would be y is equal to or greater than 0, as this function never goes below